Real numbers consist of surds, or irrational numbers, and rational numbers. So a rational number can be represented as a fraction, and when I make it as a decimal, it is recurring or finite. Okay, so all of those three can always be represented as a fraction. If you go a recurring decimal, so 0.33333333333, that's obviously going to be a third. A fraction, even if I had 0.125, well, that can be represented as a fraction. It's 125 over 1,000. Irrational numbers can't be represented as a fraction. So it's just the opposite. So the only way to represent them exactly is to represent them as a surd. So, or the irrational number could be something like pi, okay, which we know is a non-recurring infinite decimal. Okay, so for a surd, like we could take surd 2 as an example. So the only way that I can represent the square root of 2 as an exact is to leave that radical or surd sign in. Okay, otherwise I'm going to get a non-recurring infinite decimal. To simplify surds, we need to know the square of numbers 1 to 12, 15, 25, and 30. They will help us because then we can look for their squared. So, for example, if it's 3, 3 squared is 9. If I look for perfect square of a number 9 in a surd, see if it is a factor, then I can take it out. It's a good habit to write your squared numbers on the top of your page, and then you can just always reflect back on them. So I can go, well, 24, what goes into 24? Well, let's see, 9, no, that's too much, so I've got to go back down. 4 goes in there, how many times? By 6. 6 is a product of 2 primes, therefore it will not simplify anymore, so I just got to square root the 4. Remember, that's the same as the square root of 4 and the square root of 6. I can separate them. The square root of 4 is 2, so I'm left with 2 surd 6. You shout aloud, but I can't hear a word you say. I'm talking loud, not saying much. I'm criticized, but all your bullets ricochet. You shoot me down, but I get up. So multiplying surds, just remember that if I've got a number on the outside, like such, then those get multiplied together, and the numbers within the radicals, so within these square root signs, they get multiplied together. But before we do anything, it's better off to simplify. Okay, so you know that the inside surds will just become AB, and whatever's on the outside, they'll be multiplied together. So let's simplify first. So surd 6 is fully simplified, so that stays the same. And then I just have to do surd 12. Well, 12 is the same as 4 times 3. 4 being my perfectly squared number. The square root of 4 is 2. So I've got 8 surd 6 times 6 surd 3. Because square root of 4 is 2 and 2 3s are 6. Now I multiply through. So 8 times 6, 48. 6 times 3, 18. Now, does a perfect number go into 18? Yes, it does. So I've got 48. And in my surd, that's the same as 9 and 2. Square root of 9 is 3. So I'll have 48 times 3 on the outside and surd 2 on the inside, which leaves me with 144 surd 2 finished, fully simplified. Remember, you can't simplify surd 2 anymore because it's a prime number. So if I square root that, that's when I know I'm going to get that non-recurring infinite decimal. I'm bulletproof, nothing to lose. Fire away, fire away. Ricochet, you take your aim. Fire away, fire away. You shoot me down, but I won't fall. I am titanium. You shoot me down, but I won't fall. I outside selenium. Okay, so for dividing surds, it doesn't matter which form we use of these three, you just need to find the one that applies to the problem best. So in this case, even though I could simplify down this fraction, I'm going to simplify by separating them into two separate surds. So I'm going to end up with -2, and on the top will be the surd 27, and on the bottom I'll have surd 100. And the square root of 100 we know is, sorry, that looks like a plus, that should be a 7, is 10. So on the bottom I'm going to have 10, and on the top I'm going to have surd 27 and -2 at the front. So I've got -2 surd 27, which is actually 9 times 3, over 10. The square root of 9 is 3, so I've got 3 by 2, which is -6. Surd 3 over 10, 6 and 10 cancel down. 2 is a factor of both, so I'll end up with -3 surd 3 over 5. Fully simplified there because the surd 3 we know is a non-recurring infinitesimal. The main thing to remember when adding and subtracting surds is that we need to have like surds. So that just means that when I add them together, they need to be the same. So if we take this example, at the moment I've got surd 32 and surd 18. They are not simplified, and I can't add and subtract until they're simplified because I actually don't know if these are like. Okay, if they all have, for example, surd 2 in it, that's probably what we're looking for, given that this one's already simplified. So if it ends up that I've got two different ones, surd 3 and surd 2 as my answers, then they can't be combined. Just like if we were looking at algebra, we can't combine x and y together, but x and x, of course, add together to give 2x. So let's simplify these first. So 32 is 16 times 2. 7 surd 2, as I said before, is already simplified. And 18 is 9 times 2. So that should be 9, not 91. So I'm going to square root the 16 to give me 4. So I'll have 2 times 4 on the outside here. Surd 2 on the inside. 7 surd 2. 9 is the square of 3, so the square root of 9. I'm going to have 4 times 3 on the outside here and surd 2. So 8 plus 7 plus 12. And they've all got the same surd, which means that they are like, so I can actually combine them. 8 and 7 is 15, plus 12 is 27. Surd 2. Fully simplified now. So all I need to do is state that's the answer. Surd 2, you can just go back and check and go, well, surd 2 is, of course, a non-recurring infinitesimal. Even though we've got add or plus between all of these, same thing applies to subtracting, so I won't do another example. If you want more examples on this, please go to 12.3 in your textbook. Cut me down, but it's you who have the feather to fall. Goes down in haunted love. Raise your voice. Sticks and stones may break my bones. I'm talking loud, not saying much. Surds and the distributive law. Just remember that instead of having actual like a x, y in these, I've got surds. So it's the same thing, we multiply through like we would if we were using this for algebra, and then we simplify using all the surds information that we've already had. So let's do an example. Okay, so in order to use the distributive law for this example, I need to make sure that I multiply each of these terms with inside the bracket by that which is outside the bracket. Okay, so -4 surd 5 by 1 is of course just itself, so I've got -4 surd 5. -4 surd 5 by -2 surd 5, a negative and a negative makes a plus, so I'm going to have plus 8 surd 25. Remember that the numbers get multiplied together and the surds get multiplied by together. And then I'm going to have negative and plus, negative 4 on the outside. 5 times 15 is 75. And now I start to simplify. So the first term there is already simplified. The second term will be 8 by 5. Of course, the square root of 25 is 5, so I'm going to have 40. And 75 is 25 by 3, so I'm going to have 20 on the outside and surd 3 on the inside. Since I don't have any like surds, that's fully simplified now and I cannot combine it any further. Don't forget that to use the distributive law, and especially when you start using conjugate for the next bit, which is rationalize the denominator, that we need to remember what our two perfect or special products rules are. So that includes the difference of two squares and the perfect square rule. Have a look at these so that you make sure you understand where it's coming from. Just remember that when you are using the difference of two squares, rather than a squared minus b as your result for the surd, you're going to end up with a minus b because these cancel. And remember, for the perfect square rule, you're going to end up with no squares at the end because you had surds to begin with, and the middle will be a combination of those two surds, two lots of that on the outside. And same with the minus, except it's just a negative there. I'm bulletproof, nothing to lose. Fire away, fire away. Ricochet, you take your aim. Fire away, fire away. Shoot me down, but I won't fall. I am titanium. Shoot me down, but I won't fall. I am titanium.